Hello and welcome to the lecture about insertion sort. Insertion sort algorithm is a simple and comparison-based algorithm in which the array items are compared with each other to sort the array. So let's get started by an example to show how this process works. Suppose we're given this array. We start from left to right. The first element in the array is always assumed to be sorted. Then we need to take the next element. We must always compare the next element with previous one. Therefore, initially, we must put first item in the sorted list. Suppose that we want to compare 24 with its previous item. Because there is nothing to compare with, then we suppose the first item is sorted, and then the rest of the array will be remained in the unsorted list. Now it's the time to see how this process will work by codes. Initially, we define a function for insertion sort. Let's get started and call insertion sort function. In the first line, there is a for loop and the length of the array is 5. And it will start by 1 because, as discussed earlier, the first item with index 0 is assumed to be sorted. So in the next line, we assign ARR of I to a variable called key. This is a variable for validating the correct position of the item that we are comparing with other items in sorted list. In a nutshell, for example, 15 is the key and we want to know if this item is in its correct position or not. If it is greater than the previous item, then it is in the correct position. Go to the next line and define a variable called j, which is equal to I minus 1. Then go to the next line and check the condition. The first condition is true, and the second one is also true. It means that the item in the sorted list is greater than the key. Because we want to sort the array into increasing order, then the items in the sorted list must be less than the key. To find the correct position of the key, we need to shift items in the sorted list. Go to the next line and swap 15 with 24. Now move on to the next line and decrement j. When we decrement j, then the condition becomes false and we cannot proceed with the while loop. Then go to the next line and assign key to the ARR of j plus 1. And it means that the correct position of the key was found. Now increment I, and this time I is equal to 2. Then go to the next line and assign ARR of I to the key. Determine j value in the next line and check the condition in the following line. The value of j is greater than 0. However, ARR of j is not greater than the key, and it means that the key is in correct position. Go to the next line and assign key to the ARR of j plus 1. And then go to the first line of the function and increment I value again. Assign ARR of I to the key and determine j value in the following line. J is equal to 2. Then go to the next line and check the condition. ARR of j is greater than the key. Therefore, go inside the loop and swap 18 with 44. Now we must check if the previous item is also greater than the key or not. Decrement j. Then step backward. Check the condition. ARR of j is greater than the key. So go inside the loop and swap 18 with 24. Then decrement j to check if 15 is greater than 18 or not. As is observed, ARR of j is not greater than the key, so stop executing while loop and go to the next line. Then assign key to ARR of j plus 1. Go to the first line of the function and update I value to 4 because I is from 1 to 5, then 4 is the last iteration that we are allowed to do since the upper bound of range function. Then go to the next line and assign ARR of I to the key, which is equal to 26, and then determine the value of j, which is equal to 3. Therefore, go to the next line and check the condition. As you can see, ARR of j is greater than the key. So go to the next line and swap the ARR of j with ARR of j plus 1. Then decrement j to check if there are any items greater than the key. The condition is false because ARR of j is not greater than the key, and it means the key is in its correct position. And lastly, go to the next line to accomplish the execution. That's it, and thanks for watching this video.